Hello students, today I'll explain assignment of transformation where I'll explain scaling. Scaling is a transformation where we can change the size of polygon. So here program is already developed. So I'll explain this code. Here first we need to add all the header files which are required. Then there is a class definition. There is one class transform where we have taken all the variables matrices which are required, and here there are functions. So there is first variable a. This matrix is used to store the original polygon. The size of this matrix is, that is, max by 3. Here max is a predefined constant and its value is 20. So at the max we can store 20 vertices. Then there is another variable t where we are using it to store the transformation matrix for scaling. Then after transformation, the transform object will be stored in variable b. So the size of b is again max by 3. So there are 3 columns in matrix A and B. So why 3 columns are required? Because we are doing this transformation with homogeneous coordinate system. That's why third column is required. Then there are some variables mid-x, mid-y, max-x, max-y which are required in coding, and n is here the number of vertices. Then there are some functions. So first function is print axis. This function is used to draw the x and y axis. Then there is another function accept. This accept function will accept polygon. This function will store all the vertices in matrix A. Then there is another function display. Display function is used to display polygon. It takes one argument. So as per the argument, it will display the polygon. So same function can be used to display original polygon as well as transform polygon. So same function can be used to display transform polygon. So for that we need to pass here matrix B. Then there is another function scaling. In this scaling function we are accepting the scaling factor Sx and Sy and forming the transformation matrix. Then this transformation matrix will be multiplied with the original matrix and it will form the matrix for transform polygon. In this scaling function we are going to perform the matrix multiplication. So here we have another function to perform the matrix multiplication. This multiplication function is taking 3 parameters: first matrix, second matrix and third matrix. So this function is, it takes first 2 matrices, it multiplies and store the result in third matrix. So we'll see all these functions coding. So very first function is print axis. Print axis, this function is used to display the x-axis and y-axis. So with this function we can divide the screen into 4 quadrants. So to divide the screen into 4 quadrants we need to find out the mid-x and mid-y. So to find this mid-x, mid-y we are going to use here function getMaxX and getMaxY. So from getMaxX we'll get the max-x value, and from this max-x we are finding the mid-x. Similarly we are finding mid-y, and here we'll draw line for x-axis and y-axis. After drawing this x-axis and y-axis, now the further code is just to display the small line after the 50 interval on x-axis and y-axis. So on x and y-axis it will display the numbers in the range of 50. So this way print access can be coded. Then next function is the accept function. Accept function, first it will accept the total number of vertices. So the maximum capacity of A matrix is max. So there we can store 20 vertices in this code. So our n must be less than equal to 20. So first we'll accept that how many vertices are there in polygon. Accordingly, we'll accept the x and y value for all the vertices. So this outer for loop is for the number of vertices, and for every vertex we have to accept x and y value. So x value will be stored in the first column of matrix A, and the y value will be stored in second column of matrix A. So this way we can store x and y value in matrix A. As we are using the homogeneous coordinate system, we need to set third column of matrix A, and third column will be 1. So that will set by using this code. After accepting all the value, we can display this original object. So for this we'll call first print access function. It will print the access. Then we'll display original object by calling this display function, and we'll pass a matrix to this display. So this display will work for original polygon. So this function will display original polygon. So this is about the accept function. Then how this display function will work? Display will take the parameter and it will work for the parameter. If we pass A, then it will work for A. If we pass B, it will work for B. So it will take that matrix. So if there are n values, then it has to draw n edges. So here it will draw line from first vertex to second, second to third, third to fourth, etc. And at last it will draw line from first to last. So here this process is repeated n minus 1 time, and last line will be drawn explicitly. So that's why here there is a loop for n minus 1 time. So every time here we are drawing the line from ith vertex to I plus 1th vertex, and at last we are just drawing line from ith to 0th vertex. So this way display function will work. Here we are using line command, which is a built-in function. After display function, here there is a function of performing multiplication. It takes 3 parameters. First matrix multiplied with second matrix, and the result will be stored in third matrix. So it is a simple matrix multiplication code. So it takes the matrix A, it is multiplied with B, and the result will be stored in matrix R, which is the third one. So this multiplication code will be used in scaling function. So here there is a code for scaling. For scaling, first we need to accept the scaling factor in x direction and y direction. So here we are accepting sx value, sy value, and from these two value we are generating transformation matrix for scaling. Now what is the transformation matrix for scaling? If we go row wise, so standard matrix is sx 0 0, then second row is 0 sy 0, and third row is 0 0 1. So accordingly we have to set all the value. So t variable, which is used to store the transformation matrix. So t of 0 0 is sx, that is very first value. Then t of 1 1 is sy, and t of 2 2 is 1, and rest of all other values will be 0. So after setting this transformation matrix, now we can perform the actual scaling. So actual scaling, how we can perform? We have to just multiply this transformation matrix with original matrix, the matrix of original polygon, and after this multiplication we'll get the result, and that result will be the value for transform polygon. So we'll pass this matrices to multiplication function. So after this we'll call this multiplication function, that is first we'll pass the original matrix A, then we'll pass here T, and then we want result in matrix B, so that's why we are passing B as a third parameter. So this multiplication function will perform multiplication between A and T, and result will be stored in B. So our transform polygon is stored in B. So after this, now we can display function, we can use the display function for B. So here we'll get the transform polygon. So we have defined all the functions. Now we can write the main function. In main function, first we'll create the object for a transform class. Now this is what the code to initialize the graphics mode. Once we have initialized graphics mode, now we can call the accept function first. S1 is the object. We'll call this accept function. This accept function will accept the polygon, and after that we are calling the scaling function. Scaling function will perform the scaling, it will accept scaling factor, it will perform scaling, and it will display the transform object. So this is what the code. Now we'll see how we can run it. So code can be saved, compile, and it can be run. So first it will ask for total number of vertices, we'll write 3. So for these 3 vertices, now we have to accept x and y value. So first x, then y. Second vertex, for example, it is 100, 10. Third vertex is 50 and y is 100. So we have accepted the number of vertices and x and y value for all the vertices. Now this is what the original polygon. Here you can see the x and y axis with the interval of 50. This is what the original object. Then we need to pass the scaling factor. X scaling factor, for example, it is 2, and y scaling factor is 1. So here you can see the scaled polygon. So x value is x scaling factor is 2, so every x value is multiplied by 2, and y value is multiplied with 1, so it remains same. So this way we can perform the scaling. So similarly we can perform all other transformation. If we want to perform the translation, so here you can add one more function for translation. You can write the code for translation. In that you have to first accept the translation factor. From that you have to generate the transformation matrix. You have to call the multiplication function, and in the same way you have to display the polygon. So in the similar way you can perform all other transformations. So I hope you understood this code. So if you have any query, definitely you can ask. So thank you.